Good morning, sir. I'm Tejaswini from CSO, roll number 20BQ1A4950. The topic I've chosen for today's seminar is dynamic memory allocation. So, what is dynamic memory allocation? It is the process of allocating memory during runtime. So, as to why we have to use this is because of its merits. That is, let's say we are storing memory in the normal way. That is, we are storing memory of the data during compilation time. Let's say we have created an array A of character type of size 100 bytes, but we are given an input of only 20 elements. These 20 elements will only consume 20 bytes of memory in general, right? But since we have already created an array of size 100, what happens to the remaining 80 bytes? Since we cannot use these 80 bytes in any other way, these 80 bytes of memory are simply wasted. But it's not the case in dynamic memory allocation, because what we're doing here is we are making the system to assign a certain amount of memory at a particular address, since we are mentioning the size of the data which we are going to give as an input in the program during runtime. So the other advantage is that sometimes maybe when we are dealing with huge amounts of data, we just wanna clear data and maintain the storage space of the system as safe as possible to avoid any malfunctioning of the system, or maybe due to other circumstances we just wanna omit or erase a certain amount of data which is no longer necessary in the program. This is not possible by static way, because when we are storing data during compilation time, either we can erase it by deleting the whole program or exiting the program, which leads to a huge data loss, which is not useful at all. But this can be done by dynamic memory allocation. So in dynamic memory allocation, by using a certain function called free function, we can erase desired data from a pointer in which the data is in by giving the memory, that is releasing the memory back to the system. That is, we can do this at any particular point of time in the programming. So coming to types of functions in dynamic memory allocation, there are 4 functions in it. They are malloc, calloc, realloc, and free function. Let's see how these functions work and what are their syntaxes and what role they play in dynamic memory allocation in detail in the following program demonstration. So let's see how the 4 functions work for this demonstration program. Now let's ignore all these extra statements which are used later in explanation. So we have taken a program to enter the data using dynamic memory allocation and print the entered data. So let's see if it works or not. Now, coming to the functions, the first 2 functions are malloc and calloc. Both are used to store the input data by dereferencing the pointer. Here, in the taken program, we have taken a pointer of character type, and we are using malloc function to store the data in this pointer. Now see, the syntax of this malloc function is pointer variable name equals to data type of the pointer variable asterisk malloc and size in bytes. Here the size in bytes is taken as n into size of character, because n is the number of elements those are entered and size is the size of each element that is entered, that is the size of the character. So this gives the overall size. Now let's see if the program works out by using malloc function or not. So it's asking the number of elements to be entered. Let's say it's 3, and see, clearly it has taken the input ASD and given the output. It stores the 3 elements, that is which we given an S3. 3 elements are stored and it is giving the perfect output. Now let's see if it works out by calloc function or not. Now the syntax of calloc is not that different from malloc. The only difference is here we are directly giving the overall size, but here we're giving n, that is the number of elements, and then size of each element. Because we are seeing the syntax difference because due to the main difference between malloc and calloc functions. The difference is the malloc allocates single memory block of contiguous memory for the data we stored, while the calloc function, it allocates multiple memory blocks. That is, as we've seen before, For a malloc function, one way of giving three elements as input, all these three elements are stored in a single memory block. Now let's see how it works out for calloc function. Once again, it's asking how many elements to enter. Let's say it's 3 and enter the elements AST. So if we see here, there is in this console box, there is not any particular difference between the calloc and malloc input, but the main difference is not seen here because basically both are stored in the memory, but in malloc function, the three elements which we are giving as input are stored in a single block, while here for calloc function, even if we cannot see here, these AST, they are stored in separate memory blocks. That is, A is stored in one block, C S is stored in another block, and D in another, and it works out continuously. So, as we in this way, both malloc and calloc functions are used to store the input data in dynamic memory allocation by dereferencing the taken example pointer. Now let's see what is let's wait a second. Let's see what is realloc function. So the realloc function, so if the memory allocated is not sufficient, that is, we are giving some size of the memory, right? In either malloc function, in calloc function, we are giving some size. If later in the program, if we get to know that this memory is not sufficient, then to increase that memory, that is to change that memory, we are reallocating it. So for that, we use the realloc function. So the syntax of realloc function is uh, pointer variable equals to data type of the pointer variable asterisk realloc and the pointer variable name and the change to the new size. Here before, when we are giving n, let's say in the both the previous examples we have taken n as 3. So later in the program, if we decide we want more memory than that, let's say we are giving 10 bytes here. So let's see in this for loops below, clearer we can see we are giving 6 elements as input while we are taking n as 3. Let's see how it works out in console. So let's say take n as 3, that is only 3 elements can be entered here. N, A, S, T, it's giving an output perfectly. Now enter the elements again. That is, here what we have done is we are using the realloc function by increase the limit of the data to be entered, the limit of the elements to be entered to 10 elements from 3 elements. Let's see if it can take from this for loop there is 6 elements or not. A, S, E, S, S, F. Clearly, it has taken all 6 elements and given the output as all 6 elements. That is, the amount of data, that is, the size of the data that can be entered by using this malloc function and calloc function can be increased or decreased by this realloc function as per our necessity. So, coming to the last function of this dynamic memory allocation is the free function, as which we discussed before in the video, that this free function plays a key role in managing the memory waste. That is, it helps us to clear the previously entered variables data which are of no further use in the program. Now, let's see how it works out. So, in this program, what we've done is after taking the input data, firstly, we use the printf function to print the value in p. So after completing the program, after using free function for the pointer variable p, what should happen? By using free function, clearly all the data stored in this particular pointer should be erased. That it should be freed, and the memory should be returned. The memory should be released back into the system. Now let's see if it happens or not by using free function. So, oh sorry, 1 second. Let's just ignore this realloc function for 1 second since we are discussing about uh, free function. Now, so it's asking again how many elements. Let's say it's 3 elements as A, S, F. So here, as we can see before, we given a print command to print the value in P, that is A. Clearly it's stored, first element that is stored in this pointer, so it is A, and after the elements are given as output, and after using free function, you can clearly see that after executing the printf command to give the value in P, it is not giving any value, it's just blank. It's just blank space. That is, there is no data in this pointer variable anymore because by using free function, we cleared the data in this pointer P by releasing the memory back into the system. So in this way, the four functions of the dynamic memory allocation are used in managing the memory space and using it and manipulating it as per our requirement. Thank you.